Good morning in virtual land. Click and clack here. Dr. Kuhn, welcoming you on our second week of bioethics. And we are super happy to have with us, beaming in from Little Rock, from the Donaghy Honors Scholars Program at UALR, Dr. Jessica Scott, who you will learn is not only brilliant and a prolific writer and publisher who works with our amazing honor scholars at UALR, but is a great teacher on top of all of that. So I'm going to go ahead and introduce Dr. Scott, but first let me say, for those of you working on ethics and agriculture, this afternoon I will be posting the additional readings for your paper. So keep an eye out for that. Otherwise, I have all the additional reading for everybody up. So you should be able to work on your papers very well. All right, we're very proud of Dr. Scott because she received her PhD from the University of Arkansas. Woo! Click and clack approve. Not only did she do that in environmental dynamics, she worked with the boss, Peter Ungar, amazingly renowned biological anthropologist who works on teeth, and in fact had an honors college signature seminar at the University of Arkansas on that subject. So I think that Dr. Scott has had an amazing career, but has been an exceptional associate director of the Donaghy Honors Program at UALR. And she teaches super cool classes in anthropology and science and society, which, by the way, is a really cool discipline nationally. So her research, like that of Peter Ungar, is dietary ecology and the reconstruction of ancient climate, which I assume we're going to hear about today, especially using teeth. I've learned so much about teeth and their importance for even studying the past, the history of bubonic plague. You name it, teeth are super relevant. But what's really cool, I think, about Dr. Scott is the range of her research. She studied the teeth of ancient Egyptians from the New Kingdom at sites in Amarna, Egypt. She's analyzed the teeth, are you ready, y'all, of dozens of fossil and living animals. Here's the list. I love the list, by the way. Antelope, aardvarks, lions, hyenas, saber-toothed cats, lemurs, monkeys, and apes. Awesome. She's done field work in Kenya, Madagascar, Ethiopia, Egypt, the Great Divide Basin in Wyoming, as well as curatorial research and museums in London, Paris, Johannesburg, Nairobi, Addis Ababa, Brussels, Chicago, New York, and DC. She's published way too much to be in administration. It's really quite frightening, isn't it? In top big-time journals, by the way. The American Journal of Physical Anthropology, Mammalia, the Journal of Vertebrate Paleontology, the Journal of Human Evolution, the American Journal of Primatology, that's a big one, woo, big, et cetera, et cetera. And she continues to research and publish and runs a superb honors program. And in fact, Dr. Scott is headed to California to present research tomorrow. So we are super happy that she had the time to beam in and work with this talented crew of honor students. So take it away, Dr. Jessica Scott. Click and clack, say, woo!
Well, Linda, I don't know exactly how I'm going to live up to that introduction, but I will do my best. Hi, everybody. My name is Dr. Jessica Scott, and I am the Associate Director of the Donaghy Scholars Honors Program at UA Little Rock. And as has already been said, I received my PhD in Environmental Dynamics from UA Fayetteville. I think the reason that climate change is so fascinating to me actually comes from, it is the same reason that I was excited about doing the Environmental Dynamics program. I am super interested in interdisciplinary problems. And I think it fits really nicely with the whole concept of honors. We don't just want to look at a problem from one disciplinary point of view. And that's why I was super excited to be part of this course, because even in science, these questions of ethics, of philosophy, of values are often sort of considered that there's a wall between what we do as scientists and what society ends up doing with that science that we study. And I think that the idea that there's really that wall there is kind of a lie we tell ourselves. We really do have to engage with these questions of ethics and values. And I think climate change is one of those problems where science really butts heads with ethics and philosophy. So I'm super excited about the interdisciplinary nature of this course, but also the engagement with something that really falls outside of the realm of science. I'm going to apologize in advance. I'm going to take a lot of drinks of water today. I had the worst allergies last week. Wasn't COVID, I promise. The worst allergies last week, and I'm still a little dry. So as you heard, I've done a lot of research and a lot of different things, and the real focus of all of that work, no matter which species I was working on or where in the world that I was working, the questions always centered around using animals and being able to reconstruct their behavior in the past to tell us something about past climate. Most of the way we look at past climate are sort of these big regional models for what climate was like. But all we have to do is look at, here in the United States, climate can, and not weather's very different, but climate itself can vary dramatically from area to area based on geography. And so being able to look smaller scale is really important for us. So I think that what I want to shift and talk about today is really this focus on climate and what we know about climate and sort of what that climate can tell us. But I'm not going to talk about my research today. Teeth are fascinating, and I appreciate the shout out for teeth. But I want to move to the present and to talk a little bit about what we know about climate change and how ethics can shape what where's that? What is this? Oh, no, that went away, John. I don't know what you did, but I'm still here, I promise. I'm going to share a screen in just a minute, so looking at me doesn't matter all that much. But what I want us to focus on is sort of what we're going to do, not only as individuals, as a nation, but as a global community, because climate change is a global problem, for being able to navigate the difficult decisions that climate change is facing us with. And what the role of science is going to be in that. And so that's kind of the direction we're going to go today. I do want to spend a little bit of time talking about the science itself. So that's where I'm going to start. Most of you, I suspect, have some familiarity with climate change. It's certainly a problem that your generation has grown up with and hopefully been exposed to. But I suspect some of the things I'm going to talk about today are going to be new for a lot of you. But we do kind of have to start with those basics. But eventually we're going to shift talking a little bit about the collective action problem, how we get people to do things that may not immediately be appealing, which is a very challenging problem in policy, and then focus a little bit more on ethics and the ethical questions that we face and how maybe some of our collective values are going to have to drive some of these decisions. I want to be really upfront. I'm not here today with an agenda to push or a set of plans that I want to advocate for. Frankly, if I knew how to address climate change in ways that are just and equitable, I would have a much better job title after my name. So I don't have that. I'm not going to claim to have that. But I'm here to pose some ethical dilemmas. I think sometimes climate change, we sort of look at as this issue of science. Like, science has told us this is happening. Science has kind of told us what we need to do, but it's not that simple. And I think we need to kind of engage with that. Now, it's a super complicated topic. I could spend our entire time together today, plus your seminar hour, literally just talking about the impacts we see from climate change. And I don't want to do that. we're all way too familiar with those images of sad looking skinny polar bears on floating, bits of dwindling ice, and they make us all sad. And there are real consequences for other species, but I want us to be a little more selfish today. I want us to sort of focus on people who often, interestingly, get lost in a lot of the science-heavy discussions on climate, and to think about maybe what some of the factors are that we need to weigh in this decision. So I'm going to share my screen. I do have a lot of visuals. I will share them later so they can be up on Blackboard. So somebody's gonna, let's see, Chrome tab. I don't want Chrome tab. I want my keynote. Okay, and then it's telling me it wants to. Okay, what are you seeing, John?
We are seeing you, but let me move down. Just in
Okay.
case this is hindering it in some way, but it shouldn't be, because we're doing what we've been doing every day.
Yeah. It's telling me that we need browser access, but
Okay, that's your computer saying it needs permission to open your browser, to open, to put Zoom, your presentation in a Zoom web show, I think.
okay, so where do we give it that? Screen recording. It's asking for me to do something with screen recording, which it looks like permissions are there for.
Okay.
Okay. Sorry, guys. I guess we thought we tested stuff, but not quite everything. That's fine.
If you can't do it, you can always email it to us and we can put it up.
Permission.
Oh, well, this happens in Zoom land.
It happens. It could be our IT department has some eccentric settings in the way that our own IT department has some eccentric settings that I don't understand why they choose them.
Indeed. I'll click. I think the professor's come back in. All right, let's see if this works.
Oh, I know what it is.
What is it? Oh, are you muted now,
You
Jessica?
are muted, Jessica.
Well, that was drama I wasn't counting on. Okay, John, if you will add me as a host again, hopefully this will work this time.
Maybe the second one down.
Seems like the problem is the recording. My computer didn't seem real crazy about letting you record something I was sharing.
Huh.
But I think I have changed the settings.
Okay. Because you're an anthropologist, you know what you're doing.
I know exactly what I'm doing, right?
Always. There you go.
Now we can all see what we're supposed to see. Yay.
Bravo.
Okay, so once again, let's dive right in and talk about how we consider equity in addressing a problem that we sometimes call the perfect moral storm. So I want to start here. This image is known as the Blue Marble. It was taken on December 7th, 1972 during the last Apollo mission. And I love using this photo because looking at the Earth from space shows us the true interconnectedness of our planet. And what I see when I look at this is a set of systems: the ocean, the atmosphere, the land itself, and life on it. And all of that works together to make it possible for us to live and thrive on what astronomer Carl Sagan called our pale blue dot. Now, I invoke Sagan because, I was talking earlier about this idea of interdisciplinarity and this connection between science, sometimes seen as cold and distant, to ethics, to morality. And Sagan really liked to bridge that gap and used images like this to talk about the vulnerability of the Earth and the responsibility that we have to take care of our planet. Now, we've all heard a lot about climate change, but I feel like when we're going to discuss it, it boils down to three questions. Must we change? Can we change? And will we change? These questions are going to be our roadmap for today. Science can answer the first two, no problem. The third, however, exists in the realm of ethics. And we're going to start today by talking a little bit, doing a bit of an overview over the first two before we sort of move into these bioethical dilemmas. More than 98% of climate scientists agree that the Earth is heating up and that our actions have caused this. So why is it so hard for people to understand and accept this conclusion? Well, I mentioned Earth's interconnected systems. Those connections of systems to each other are really why climate is so difficult to study. One change in one place can have far-felt effects that can be difficult to accurately predict. And if we get slight fluctuations in multiple parts of the system, the end results can be very different. And I think that's a hard thing for non-scientists to understand. We're all taught science in this way that A plus B equals C, when in fact, actual science, especially developing science, is much more fluid and subject to change. And of course, we know that global warming can be caused through natural processes, although not at the rate that we're seeing today. The evidence that warming that is happening today is not natural is really overwhelming. And human-induced or anthropogenic climate change has about as much acceptance as any question in science. So science is going to say, yes, we must change. And the scientific community has been telling us that for decades. But I think if that answer isn't good enough, all we really have to do is look at the world around us and what's happening to it. So I want to start by talking about our atmosphere. The sky is not that vast, limitless expanse that it looks like when we stand on the ground and look up. It's actually a very thin shell protecting the planet. And yet we're putting about 110 million tons of man-made global warming pollutants into the atmosphere every single day. And this pollution, especially carbon dioxide, is building up and it traps heat. So many of you are familiar with the basic science of global warming, and this has been understood since the 1800s. This is not remotely controversial science. You all know that Earth gets its energy from the sun. Solar radiation travels from the sun to the Earth's atmosphere, and about half of this energy passes through the atmosphere to the Earth's surface and warms it up. When sunlight enters the lower atmosphere, some of that energy is going to be bounced back into space when it comes into contact with reflective surfaces. So things that are really light colored, like ice, certain kinds of water, or cloud cover. As we'll see later, there are other things that can be reflective as well. Things like white paint, certain kinds of white paint can be super reflective. But in this broader global scale, we're talking about ice, we're talking about clouds, and we're talking about certain types of shallower water. Now, some of that energy, however, is not going to bounce back into space, and it's going to be trapped in the Earth's atmosphere, and it's going to warm the atmosphere. Now, this is a good thing. We need this. It allows life on Earth to thrive and keeps us in what we call the Goldilocks zone for life. But if too much heat gets trapped, things can start to become far too hot. Carbon dioxide, methane, and other global greenhouse gases absorb a lot of solar radiation, and they trap more heat in the atmosphere. So as they build up, less of that outgoing radiation can bounce back and get back out of the atmosphere, and it stays trapped. And we've been thickening the atmosphere with these things for 100 years, more so if we really go back to the Industrial Revolution. In simple terms, when people like me look at the historic climate record, what we see is that when levels of carbon dioxide were higher, the Earth was a lot hotter. So think about times of the dinosaurs. And when the levels were low, the Earth was a lot cooler. Now, much of the global warming we see today is caused by carbon pollution from fossil fuels. And other important contributors to this are going to be things like deforestation. You're taking away a natural carbon sink, and you typically do that not only by cutting trees down, but in many parts of the world by burning forest, which itself is going to release more CO2. Through transportation, which we're certainly going to talk about today. Agriculture, also going to be really important. And then in just industrial processes, things like the refinement of something like coal. So what do we know about warming? Well, as you can see here on this graph, there we see global rise in greenhouse gas emissions, particularly carbon dioxide, beginning to rise during the Industrial Revolution, and then really taking a sharp spike after World War II as the modern burning of fossil fuels really begins in earnest globally. And that rise begins to become very, very steep as nations like India and China both grew in population and fully industrialized in the late 20th century. Now, if you notice at the very top of the curve, so we get up closer to 2015, 2016, it seems to level off. This was a pretty good time period for the environmental movement. The Paris Climate Agreement was signed 2015, and it was the first time that global carbon emissions became decoupled from global gross domestic product, which is a really important marker, indicating that while the global GDP continued to grow by about 3%, we actually saw about a 0.5 point reduction in global emissions. So suggesting that we can continue to have economic growth while we're also reducing the use of fossil fuels. Now, this didn't last long. Proves to us it's possible, but it didn't last long. Global emissions have risen in the last few years, with the exception of a little blip sort of right at the beginning of COVID. So we know we're burning more fossil fuels. We also need to know if the Earth is getting hotter. Now, according to data from the National Oceanic and Atmospheric Administration, 2021, so last year, was the hottest year on record, which beat out the previous hottest year on record, which was 2020. Which beat out the previous hottest year on record, which was 2019. And we could keep going like this for a while. We're going to have to go back a number of years before we stop having this new global temperature record every year. According to NOAA and NASA, 2021 had a global temperature a little over 2% Fahrenheit above the 20th century average, and almost a full degree above the previous record set in 2020. Models show that if we took human-induced climate change factors out of the equation, the chances of that warming occurring naturally would be about 1 in a million. So the connection to carbon emissions is pretty clear, and especially when we look and see that these rising global temperatures start within a couple of decades after this big rise in carbon emissions. So we really see this very similar pattern, suggesting a strong correlation between these two factors. Now, I think these data are going to be really telling for those of us who live in a climate with disturbingly hot summers. What we're looking at here are summer temperatures and how they deviate from the average over a period from 1951 to 1980. So cooler than average, average, and warmer than average. We see a pretty basic bell curve in this roughly 30-year time period. So we're going to lock this in as our baseline to sort of what we're going to compare to as we move forward. And watch what happens as we move closer to the present. As we move into the 80s, we see temperatures begin to skew toward the hot end of the spectrum. And we also see the need to create a new category for extremely hot temperatures, which wasn't there before. It was the very tail of that bell curve, didn't even need its own category. The trend is going to continue as we move into the 90s, and this extremely hot category is going to enlarge. Now, in the past 4 decades, hot summers, certainly here in places like Arkansas, have become more frequent, and cooler summers have become much more rare. In fact, the extreme temperature events that used to cover only 0.1% of the land now cover 22.1%. And that's really just since the 70s. So this is definitely an increasing and modern problem. 2021 was the 46th consecutive year on record with a global temperature above the 20th century average. So this isn't a blip. This isn't just a warm snap. This is a pattern that is really becoming clearer and clearer every year. So what this means is that we can expect to see increasing temperatures continue all over the world. And therefore, we can expect all the consequences that come with warmer weather, including a rise in heat-related deaths for people and livestock. And I said I really wanted to center on human impact today. So that's what we're going to try to do as we talk about some of these effects. Heat waves kill thousands of people every year, especially in developing countries where they don't have access to the same kind of infrastructure and particularly clean water to be able to combat it. But even in the US, heat is the primary weather-related cause of death, and that becomes much more serious when heat waves strike cities up north where air conditioning isn't standard in buildings. I know that sounds crazy to us in the South, but that is very much the case in northern cities and homes in those cities. So heat is going to be a real problem for people. But all that heat doesn't stay in the atmosphere itself. About 93% of it gets stored in our oceans. And according to the Intergovernmental Panel on Climate Change, it's virtually certain that ocean surface temperatures rose between 1971 and 2010, with increases going down up to 2,000 meters. This isn't just slightly warmer water at the surface. This is really beginning to heat up those deeper levels of the ocean. And half of that rise has occurred in the last 20 years, which again shows the rapidity with which this is happening. Most of this warming has occurred at the surface, or at least the highest amount of warming. And this is where ocean temperatures are most likely to impact the destructive power of storms like hurricanes and typhoons. And so one of the factors that feeds these superstorms is that the Earth's average temperature, as that increases, the rate of evaporation over oceans and evapotranspiration over land is going to increase along with it. And so all of this increases how much water vapor there actually is out in the atmosphere. Warm air is going to have more moisture holding capacity than cool air. So as air gets warmer, it can hold more water vapor. And what we see is that there's about 4% more water vapor over the oceans now than there was just 30 years ago. So this is a pretty massive increase. And while this might not have any obvious impact, it really does. This leads to heavier storm events like this rain bomb photographed last year in Texas. And with this comes weather factors that impact communities, mudslides, heavy flooding, and incredible amounts of economic damage. So right here, just last year in our neighboring state of Tennessee, we had what we call an atmospheric tsunami. So one of these massive rain bombs. They received about 17 inches of rain very, very quickly. And it killed 22 people due to flash flooding. And these kinds of events are happening all over the world. We could look at these all day. Warmer ocean temperatures act as fuel for storms, and this results in more intense storms, rapid intensification of storms, and higher wind speeds. Those warmer oceans also increase the amount of water vapor that is available for storms to use, which results in heavier rain and more flooding as the storm moves over land. And since warmer water takes up more physical space, warmer waters actually, the water molecules expand. So when water's warmer, it rises. This, along with what we know about melting ice caps in the Arctic and in Antarctica, has caused sea level rise all over the world. And that means we have higher storm surges, and water's going to move further inland with increased flooding. So Hurricane Harvey in 2017 is a storm that I think pretty much everyone in this region is at least somewhat familiar with. This was this massive hurricane that basically sat on Houston, causing somewhere between 30 and 65 inches of rain within a few days. I can tell you there's not a city in the world that is prepared for 65 inches of rain. And so the human cost was huge. Harvey was described as a 1 in 500,000 year storm. And so a lot of people say, wow, this was just a freak incident. But I think we have to look at why it was so devastating and how that can be linked to climate change. Well, first, the water that this hurricane crossed to be able to reach Texas, so this path across from the Yucatan to the Gulf of Mexico, the waters were 7 degrees warmer than usual, and this is beginning to happen more and more frequently. And that heat went deep, and this provides a huge amount of fuel and evaporated water for the storm to utilize. It basically fuels it. Had those waters been colder, what would have happened is that cold water would get churned up. It wouldn't produce the kind of water vapor, and it basically short circuits storms. And this is the historic pattern for typhoons, cyclones, and hurricanes. As soon as they get over really deep, really cold water, we begin to see some of those short circuiting effects happen. Instead, these warmer waters in the Gulf actually fueled it, made it stronger. We also know that Harvey was a very slow moving storm. And if there is one reason that we are seeing more damaging storms in the last decade, this is probably thought by most climatologists to explain a lot of that. So the slow moving nature of the storm obviously means we have a lot more rainfall and eventually more flooding. Research suggests that melting that we all know occurred in the Arctic is causing a wavier pattern in the jet stream. So it's causing that to have these really big crenulations. And the jet stream, as hopefully all of you know, is sort of these high atmosphere, narrow bands of winds, and they're sandwiched between cold air masses from the north and warm air masses from the south. And they sort of move, air and these large storm systems. So wavier patterns slow down those jet stream winds, and because there's a lot of curvature in them, and so that slows down, and that means storms are more likely to move more slowly all over the world. And when we look at storm patterns globally, it absolutely seems to be being affected by this pattern. So what happened in Texas is, and has happened in other places, is Harvey sort of arrives in Southeast Texas as this fueled storm, and then it stalls out. It gets caught between this warm and this cold air mass, and it sits. And what we saw is this led to record-breaking flooding, the displacement of 42,000 people, and massive loss of resources, leading the Texas governor to estimate damages between $150 and $180 billion. And these same patterns have repeated all over the world. We saw this just last year in Haiti, where over 10 inches of rain fell within a couple of hours, devastating, especially following an earthquake. So this really terrible. In the Philippines, we had more than 15,000 people who had to evacuate to flee floodwaters from one of these storms. Guatemala, mudslides caused by hurricanes killed at least 50 people. And South Sudan, where just about less than 2 years ago, we had more than 600,000 people displaced by flooding from storms. And all of this has real costs. And it's especially concerning because in all of these countries, it's the poorest who are affected the most, which is something that has been repeatedly noted by world leaders like His Holiness Pope Francis. This is true most places, and especially when we look on a global scale. So the same heat that evaporates water from oceans also pulls moisture from land, which can lead to droughts, leading to crop shortages, famine, and massive amounts of damage to local and national economies that affect people's quality of life and opportunities. A flash drought in 2017 in the US High Plains destroyed more than half of the wheat crops, which not only affects US farmers and the agricultural economy, it also affects people overseas, where a huge portion of American wheat is shipped. And so it begins to affect food availability in other parts of the world, in a system where we really all depend on other countries. And lest we don't think those ramifications are sort of broader, consider that floods, droughts, and other climate-related hazards can cause major jumps in global food prices. The two big jumps we see here were the result of a massive drought in the agricultural regions of the Middle East in 2009 and 2010, and wildfires in Russia's agricultural regions in 2011, 2012. And the human impact is hopefully obvious. Just last month, Somalia, Nigeria, Sudan, and Yemen were all approaching famine, and more than 20 million people are at risk of starvation and require almost $5 billion in immediate assistance on things like food security, clean water, health, and sanitation. In a really devastating example of the impacts of things like this, 5 years of consecutive drought in Syria led to crop failures, livestock loss, and high food prices. All of this destroyed 60% of Syria's fertile land, turning it into desert. It still isn't able to be utilized, and forcing 1.5 million people into Syria's already crowded cities. And this has led to the refugee crisis in Syria that the world's been dealing with for the last 10 years, which has led to some pretty serious policy changes that affect people. If you follow global politics, you are familiar with the term Brexit and the decision by the UK to leave the European Union. A big part of the campaign in support of Brexit was actually focused on the problems in Syria, because those refugees had to have somewhere to go. And so they went to Europe, and they were spread in lots of different parts of Europe. And it caused a lot of anti-immigrant tensions. And so when we look at the campaigns that were used to support a pro-Brexit vote, which of course was ultimately successful, they heavily featured anti-immigration and anti-refugee propaganda. And this is going to become more and more of a problem. Now, I'm not going to sit here and honestly tell you that the Syrian refugee crisis was solely caused by climate change. But the underlying problems that led to it, drought, high food prices, competition for resources, all of these things are related to and exacerbated by climate change. Now, when we think about climate and people, we have to talk about sea level rise, because so much of the damage we project that we will see comes from this particular factor. And as we can see here, perennial sea ice in the Arctic has declined dramatically. Over the last few decades, we've seen it go from sort of year-round ice with sort of thinner ice during the summer, but basically lots of ice cover, to very thin ice during the summer and a whole lot of open water. I mean, it's changed dramatically just since 1984. And it's not just the Arctic. When we look at ice mass in Greenland, just since 2002, we've seen an incredible decline in the amount of standing ice and permafrost in this part of the world. And melt in Antarctica has tripled in the last decade. In fact, just a couple of summers ago, an iceberg the size of Delaware, maybe not our biggest state, but it's a pretty big chunk of ice, broke off the Larsen Sea ice shelf in Western Antarctica. And so every time there's melt, that water has to go somewhere. And you can sort of see this flow pattern from where we are seeing melt all over the continent moving into the oceans. If worst case scenario came true and Antarctica and Greenland were ever to completely melt, which is not projected anytime immediately, but it's a pretty terrifying possibility, global sea level rise would be more than 32 feet. And I think we all can imagine how serious that would be. Because 40% of the world's population lives in coastal areas. And around the world, these cities are highly at risk from rising sea level. Now, this isn't 32 feet risk. This is projected rise in the next 50 years risk. The top 10 cities at risk from sea level rise in terms of population, mostly in Southeast Asia. These are highly populous cities, but Miami is on this list. And speaking of Miami, it is the #1 city at risk by assets. But New York is also on this list, as well as cities like Tokyo, Hong Kong, Bangkok, Shanghai, Mumbai. These are not only very populous cities, but also cities where being able to repair damages, recover damages, extremely high. Let's talk a little bit about Miami, and it may get loud here for a second because this slide has some sound. Miami floods very regularly now, just due to tide, not just after storms, not just after some of, a big flooding event. Between 1996 and 2016, sea levels have risen almost 4 inches in and around Miami. And that rise in the last few years has accelerated to almost an inch per year. 5.5 million people live in this city. And if they can't live here anymore, they're going to have to go somewhere, which is a real concern. So these are some examples of what we call sunny day flooding. This is a normal day. There hasn't been rain. This is just what happens when the tide comes in Miami now, because the city is not equipped for these higher sea levels. This is business as usual, just normal streets. It's not unusual to see fish swimming in gutters. And in one of my favorite examples, we have an octopus in a parking lot or a parking deck. This is an actual raised parking deck, because these high water events are so incredibly common. In the balance of the century, there are more than $14 trillion of real estate assets at risk from coastal flooding. Now, the photos we've been looking at in Miami, these are taken in the US. And I think we're a wealthy, developed country where coastal properties are typically owned and occupied by people, frankly, who have good insurance and can absolutely pick up and move inland if they want to. So I think sometimes there's this instinct to maybe roll our eyes a little bit. Oh no, billionaires are going to lose their beach houses. But this is not the pattern worldwide. In so much of the world, the people who would live closest to the coasts are people who are poorer. And millions of people without resources are currently being affected by rising tides. And of course, what if there's no higher ground for these people to move to? For today, you all watched a TEDx Fayetteville talk by Dr. Donna Davis about the Marshall Islanders, who are watching their country only a few feet above sea level. We're looking at images of it here. Be inundated by the sea more and more every year. Now, I've been talking about science and what the science tells us is happening. So what happens with higher sea levels, what happens with warmer water, and how all those things affect people. But one of the reasons I love that TED Talk is that what Dr. Davis does is very eloquently make the point that this is about something more. It is about the science. The science explains to us what's happening. But at that point, the impact may have to be talked about a little differently. There are 50 island nations in the world, 20 of which are projected to disappear completely beneath the sea in the next 50 to 70 years. And those people are going to have to go somewhere. What happens to those countries? And how should the rest of the world address these problems? I mean, it's very easy to watch the video and sort of shake our heads and think that's horrible, the poor Marshall Islanders, and we feel terrible, especially with the Marshall Islands, where the US caused a whole host of problems not specifically related to climate change. So it's easy for us just to feel bad, but this crisis is going to require pragmatic action and decisions. So it's the things we have to think about. Do the Marshall Islanders still have a country when their island is gone and they're all refugees? Do they still have a country? What happens to their rights as Marshallese citizens? As US citizens, we have a certain set of rights that we gain from being US citizens. Other countries have those as well. And what happens when that country doesn't exist anymore? Do they still have those? Do other countries have to give them land to reform their country? And which countries should have to do this? And any land that you can live and thrive on, people are likely already living there. So what happens to those people who are going to be displaced? I think that it's not the same situation, but I think all we have to do is look at the Middle East and see what happens when we sort of try to take a group of people and give them a new space in a place that was already occupied, to know that this is complicated and that there will be difficulties in dealing with this. And Dr. Davis tells us we have to think even a step further when she talks about the concept of home, which is highly emotional. Home is about identity. It's part of who we are. And it is connected to place. It's about a shared experience. And it can be connected to landmarks. It can be connected to land. Immigrants all over the world experience this, whether they've been to them or not, this connection with an idea of a homeland, the place that their people come from. It's part of culture. And to have that disappear, literally disappear, never to be seen again, is culturally traumatic. She calls this a serious case of environmental injustice. And I think it's a good way to phrase it. Countries like the Marshall Islands, the Maldives, Kiribati, and Tuvalu contribute almost no fossil fuels to the environment. And yet they are the ones who are paying the price first. And it's a difficult situation. So what are we going to do to help people displaced by the climate crisis? Most at risk are the low-lying Pacific Islands. When we look at the islands that are most likely to disappear soonest, we are looking at the Pacific. These islands are just a few feet above sea level, even at their highest point, and they are rapidly sinking with those rising seas. Some of them are beginning to be proactive. So Kiribati is the first nation to actually purchase land in another country. They bought a big piece of land from Fiji as sort of a place that they can go for them to live. But it's not just these islands. Here in the US, we have just in the last year seen our first sort of true climate refugees. The indigenous community of Newtok, Alaska, has had to move their entire town due to thawing permafrost in Alaska, which has led to erosion and flooding. So they can't actually live in these places, in this place anymore. So they've had to move about 10 miles away, which doesn't seem like a lot, but in this community where they have tribal hunting grounds, they have an incredible connection to this land that now is much more difficult to access. This is also not that was a big deal. And this is also not a wealthy community. This is a community that had to get lots and lots of governmental money to be able to build entirely new homes. They're still not done. To be able to move this city and install power and roads, and figuring out who pays for that stuff is a real question. And it's going to be something we're going to be talking more and more about. And when it crosses international boundaries and we have these refugee crises, we're going to see it become a bigger problem. So forward. There we go. The Department of Defense recognizes that climate change is a huge national security risk, not just for the United States, but for countries around the world, because the displacement of millions of people is going to lead to a lot of challenges. The US High Commission on Refugees estimates that 21.5 million people have been displaced due to climate-related events, floods, droughts, wildfires, famine, sea level rise. And this is definitely continuing to increase. Across the world, over 10 million people were displaced by extreme weather in just the period, the 6 months from September 2020 to February 2021, which is 4 times more than by conflict. And, Dr. Davis talked about the fact that we have different kinds of humanitarian visas and temporary situations available for people who are forced to leave where they live because of conflict, but we don't have the same kinds of systems in place for this increasing group of people who are being impacted by extreme weather. The Lancet Commission estimates that the world could see up to 1 billion climate migrants before the end of the century. This is not a problem we're going to be able to dodge. So where do they go? As climate continues to warm, there are going to be options taken off the table because the parts of the world are going to become uninhabitable, either by sea level rise or by lack of fresh water or due to extreme heat that just will not allow a place to sustain human life. And what we can see when we look at this map is these are current conditions. These are the places in the world that truly you just can't live. It just is not possible for a number of environmental reasons. But let's see what happens when we put a 50-year projection here. Based on climate data and climate modelings, not the most extreme, fairly middle of the road climate modeling, not the most conservative, but kind of in the middle. These parts of the world are likely to become uninhabitable within the next 50 years, your lifetime. Now, I want you to kind of remember this little stripe through the map here, because a lot of these areas are populous, and these people have to go somewhere. I think it's easy for us in Arkansas to say, oh, we're nowhere near the ocean, and yeah, hot summers are no fun, but like we're not going to be, we don't live on Kiribati. But those people have to go somewhere. And, we heard about the Marshall Islanders who were already coming to Arkansas in large numbers. So this is going to affect us. So what do we do? Obviously, we can talk all day about solutions, but in general, they fall into one of a few categories: reducing carbon emissions through increasing renewable energy. So basically not burning fossil fuels anymore. It's going to be key. Increasing research into carbon capture and sequestration technology. So to basically be able to capture the carbon out of the air and stick it somewhere so it doesn't heat up the atmosphere anymore. Geoengineering, which is kind of the hot thing in environmental science right now. These different sort of sci-fi-esque proposals to reverse climate change and cool the earth off. And of course, international agreements to make sure that the earth is, the entire world is sort of committing to this path together to reduce emissions. So solutions tend to fall in one of these 4 categories. Now, if burning fossil fuels is a key cause of climate change, and it is, an important part of addressing that's going to be shifting to cleaner energy. And so let's just take a quick look. I said that science had solutions, and we do, so we'll look at a few of these. If we start with wind power, in the year 2000, the International Energy Agency projected that there would be 30 gigawatts of wind power available worldwide by 2010. That's enough to power about 700,000 to 800,000 homes. That was off by a factor of 7. And it actually reached 200 gigawatts in 2010. So it was a pretty rapid progression. By 2020, that capacity had risen to nearly 744 gigawatts, which was more than 24 times the IEA's projection for that year. So embracing of wind power definitely happening. And the capacity for wind energy has skyrocketed globally. more than 54 gigawatts, so that's a lot, installed in 2021 in more than 90 countries. And experts predict that this cumulative capacity growth for wind is going to continue by at least 10% a year, at least until 2030, and hope maybe even longer. In the US, we have about 84 gigawatts of wind power installed, which will power between 25 and 27 million homes. So this is being embraced here too. I love that in England, where the coal burning revolution really began, it now gets 26 times as much electricity from renewables, predominantly wind, as it does from coal. And in fact, there's a lot of days that they don't burn coal at all anymore. So in 2020, they used 0 coal-fired electricity on about a third of the days for the year. So that's a huge step forward. Globally, it's estimated that if we could really harness it, wind could supply worldwide electricity consumption 40 times over. And when we talk about solar, this gets even more dramatic. So 19 years ago, the best predictions from the IEA were that we would grow by about 1 gigawatt a year globally. When 2010 rolled around, we beat that goal by 17 times. And last year, by 132 times. So solar is the hottest thing in renewable energy. And the installation, that sort of this curve of increased installations is growing even faster here than it does with wind. And it's still dramatically accelerating, partly because the cost of solar cells, because of technology, has gone down. So technology and making more of them, they can sell them cheaper and cheaper and cheaper. So in 1976, when we first started seeing this tech, incredibly expensive, prohibitively expensive, almost $80 a watt. And today in 2020, it's about 20 cents a watt, and that's going down every single year as this gets cheaper. Now, China, which is a country we talk about a lot when it comes to fossil fuel emissions, is in fact installing more wind and solar than any country in the world. But we're seeing countries all over the world embrace this more and more. My favorite example is Chile. They have invested so heavily in solar. They really dug in to solar, more than doubling their output in 2015 and again in 2016. And now they have an incredible 27.5 gigawatts of solar projects underway. This is going to go for a minute. It's astounding. And Chile is actually in the position that they have closed down most of their fossil fuel plants, and they have a plan to get rid of them altogether. They are hoping maybe even as early as 2025 or 2026. So we do have some countries that are really getting on board with this, recognizing that, again, if we can harness it, the sun, we get enough solar energy every hour to meet the entire world's energy needs for a full year. It is just a matter of capture and storage. And we're seeing huge increases in the amount of global storage capacity for renewable energy that essentially expands the reach of renewables. We hear a lot about, well, what do you do when the sun's not shining, or what do you do when the wind's not blowing? And until we began to increase storage possibilities of batteries, those were totally valid questions and concerns. But that is beginning to become less of a problem, which is really, really exciting. So when we project this out to 2040, we really do expect to see technology allow for massive storage of these kinds of energy so that we can use it when the sun isn't shining and the wind isn't blowing. I mentioned transportation earlier as one of the sectors that is most responsible for carbon emissions. And so this is a sector that we really have to focus on. And electric vehicles are getting cheaper every year at a rate that I did not expect at all, even just 5 years ago. They are expected to reach price parity with internal combustion engine vehicles. So basically being equivalent, roughly the same kind of car within the next year for most markets is expected to actually be comparable prices. So you will no longer have to make that difficult decision to spend a lot more money to get an electric version of a car. And we're seeing electric vehicles become more and more common. And I can criticize Elon Musk for an awful lot of things, but not this one. We sort of have to thank Tesla for this huge increase in electric vehicles because they made them appealing to consumers. And so everybody else is jumping on board. We have seen General Motors and Ford here in the US just recently, as well as auto companies all over the world, have committed to making a switch to phasing out gas and diesel powered vehicles by 2035, which is really exciting. And I can tell you, as someone who living in Arkansas, I get super excited when I see one of those electric pickup trucks driving down the road, because it's just not something I thought I would see here anytime soon. But this is, I think we're going to see this technology take huge leaps forward just in the next few years. Morgan Stanley projects that renewables will be the cheapest form of new power generation in the world by 2030. So this is big. And we're also seeing a lot of advances in science in how to capture carbon and what to do with it once we catch it. So it's out in the atmosphere and we don't want it there. So this includes more efficient terrestrial sequestration. And sometimes this involves GMOs, which I suspect is something else you might be talking about in this bioethics course. So how we can use genetic modification of trees and plants to actually store more CO2. They're a great carbon sink naturally, but GMO modification is estimated to be able to get them to store more carbon, which is a good thing. We're also looking at better scrubber technology, so source capture. Power station produces, or a factory, industrial factory, produces carbon at its smokestacks, and better scrubber technology to sort of be able to keep that from getting out into the air. There's also a lot of investigation into geologic disposal. So once you capture that carbon, being able to inject it down into beds deep underground where it can be stored indefinitely. And there's some cool new research on chemical conversion, being able to actually take that excess carbon and chemically turn it into a stable form where it can sort of be stored long term. So there's a lot of possibilities there. And, you know, we have all of these geoengineering proposals, things that would actually try to change the Earth's temperature. I get real nervous about a lot of these because we talk about impact on people. You're talking about science that could dramatically alter certain things about the way our planet functions. So not things I think we should take lightly, but some of these proposals include things like cloud seeding to make things more reflective. So like sulfur, basically putting sulfur into clouds, and that sulfur would reflect a lot of this radiation off. Spreading iron in the ocean so that it can bond with carbon dioxide and absorb it. The real sci-fi proposals like launching giant space shades to cool the planet, block some of the sun's rays, or space mirrors to reflect a lot of that back. And then more sort of prosaic options like painting roofs with special reflective white paint so that you're basically adding surfaces to bounce all of that radiation back into space, hoping if you have some other ways to make sure it doesn't get trapped in the atmosphere. None of these have been tried. Like there's no, these are all theoretical, but there's some interesting science possibilities here. But as I said, they could have real ramifications. So putting sulfur in the atmosphere could change rainfall patterns. You could end up with ocean acidification. And a lot of the crops could fail with these giant space shields because you're not getting the amount of sunlight plants need. I as a scientist, I think stuff's super cool. I'm fascinated by it. I'm just not sure that trying to Bond villain our way out of some of these problems is really our best solution. Whatever we do, the solutions are going to have to be global and international. So international agreements like the 2015 Paris Agreement are going to be really important. So every country in the world, not in 2015, but within a few years after, finally got everybody on board, agreed to reduce carbon emissions with the goal of keeping rise in global temperature under 1.5 degrees and reach net zero emissions globally by the somewhat ambitious goal of 2050. Now, this is great, and do not think that I'm suggesting this isn't a good thing. It is. But critics have rightly noted that there's a couple of big flaws in the Paris Agreement. The first is a complete lack of enforcement mechanism. So everybody signs on, they say they're going to do it, but there's absolutely nothing to actually make them live up to their commitment. It's also been, I think, justifiably criticized for not addressing the fact that poorer countries who are trying to develop, trying to provide better quality of life and opportunities for their populations, are being presented with a roadblock, an expensive roadblock, to try to develop sustainably to meet these kinds of agreements. And there's a big added cost associated with this. So science has essentially tells us we have an indisputable problem, and it also gives us a path to addressing it. All of this, tech. We know there are a variety of ways to approach this, but in general, we're going to have to reduce carbon emissions. We're going to need to use more renewable sources of energy. As one of your readings for today suggested, global population is going to be a thing that we're going to have to think about. We need it to not rise too much because all that increases energy consumption. We need to preserve natural carbon sinks like forests and coral reefs. And we need to invest in research and especially better battery technology. So if you're looking for a field of study, batteries are the way of the future. As I said at the beginning, once we leave this realm of must we change and can we change, this techie, sciencey stuff, we enter the realm of will we change? And this is where I think ethics really come into play. Science can sort of give us a path. It can tell us, it can define the problem, and it can tell us based on different kinds of models what will and will not work to shift climate in the direction we want it to go. But world leaders, policymakers, and individuals, because we're not letting ourselves off the hook, determine whether or not we're actually going to do those things and how to implement them effectively. Science can say this strategy will do this. People have to actually accept that strategy and embrace it and use it. And there are also, I think, decisions that science can't really inform because they come down to values. One of, I think, the hardest lessons, and I suspect you guys are getting a real dose of this in this bioethics course, is that problems are rarely simple. Interesting problems are never simple. And solutions are not perfect. I have spent a lot of time over the years looking at proposals to address climate change. And I have never seen a proposal that is not going to have negative consequences for somebody. Never. And, we can't let the perfect be the enemy of the good. There is no perfect solution. So we have to recognize that any of these things that we do are going to add hardships, complications for someone. Sometimes those consequences are decreased quality of life. Sometimes those consequences are higher taxes. Sometimes there's somebody having to move to a different place. Sometimes it's killing an industry that employs thousands of people and builds up, sort of forms the basis of longstanding communities. Sometimes it's expensive upgrades that normal people can't afford, or having to replace technology and infrastructure that's already paid for with something new and more sustainable. So there are always going to be consequences. And in order to get anything done, we're going to have to think about how to get people, including us, to make tough decisions that sometimes don't seem to directly advantage them. And so this is what brings us to our other reading for today, this question of collective action. We often talk about this issue, this how do you get people to take on, to sign up for something that might not be advantageous to them. We often look at it through game theory, and we use examples like the prisoner's dilemma, or the collective action problem, which for environmental scientists, we think of this directly through Garrett Hardin's essay, The Tragedy of the Commons. If you're do different kinds of social science, you're going to go with Elaine Ahlstrom. So you got different examples of this, but for us, it's Hardin. So you read The Tragedy of the Commons for today, but sort of looking at our very simplified image here, it presents us with a dilemma for how to get people to make collectively responsible decisions against their own best interests. So we have our herds people here with our shared pasture, and they're grazing their cows in this local commons, our pasture, and each is considering whether or not to add cows to his or her herd. So make a pro-con list. On the pro side, there is clear economic benefit to the herdsperson who adds a cow because of the raw value of the milk or the meat at market. But there are also costs to adding that cow because it reduces the resources that are left over for all the cows. Hardin reminds us that these benefits and costs are distributed differently. So the benefit only accrues for the individual herder who adds the cow. So if I add a cow, I get all the benefit. But the cost is going to be equally spread among everybody. And if each herder has a goal of maximizing profit, it's rational to add the cow. So we can follow this out and see how this leads to systemic overgrazing of our common pasture. But the situation's paradoxical, right? The herder, each individual herder prefers the outcome of everybody restricting their cows because the commons doesn't get destroyed. So we all like the outcome of the pasture not being destroyed. However, each is going to make this decision about whether or not to add a cow individually. And so they prefer to add for that economic benefit. And since they all make their decisions in isolation, as opposed to collectively, the preference drives the decision, preference for economic benefit drives the decision to the mutual ruin of all, really. The term tragedy, Hardin uses it for a reason. It's very deliberate, and I think it's apt because each herder wants maximum profit, which is why they, in the long run, prefer collective constraint, but they themselves are driven to this more self-oriented path by individual decision-making. Now, Hardin spends a lot of time talking about population, which I think you're going to talk about a lot more, maybe on a different day. The applicability of that to the question of climate change, I think is really obvious, given that most of our proposed solutions for climate change involve our herdspeople, in this case, countries, voluntarily restricting their own carbon emissions, which has clear effects on their economy, on their ability to develop quickly, on the opportunities that their citizens are going to have. So the parallel, I think, is an obvious one. It's also important to remember, and this is where it starts to really get frustrating, in the case of climate change, we're not talking about 195 individual herdspeople, each with the same number of cows. We are talking about a global pasture with lots of herdspeople who only have 1 or 2 cows, a few herdsmen who have hundreds of cows, and a few herdspeople, wannabe herdspeople, hanging around on the outskirts, wishing they had a cow to put in the pasture. So not everybody starts on equal footing. And this is where this question of equity is going to have to come in when we talk about solutions. Because the problem is, once we start regulating the pasture, we are putting up roadblocks for those wannabe herdspeople who would really like to get in the game, to get that first cow. The ones with hundreds of cows have already reaped benefits from the commons, and they might now put in policies that will make it harder for other people, other countries in this case. So the problem's really complicated. And many environmental philosophers have described it as the perfect moral storm, which, if you get the reference, it's a reference to Sebastian Hunger's book about the Andrea Gale, which was a fishing boat that got caught between three enormous and dangerous storm systems and sort of trapped in between all of these things. And we talk about the climate crisis as sitting at the sort of convergence of a number of issues that make it difficult for us as involved actors to behave and make decisions ethically. Now, there are a lot of individual factors that we could talk about, but the three I want to focus on are that the climate crisis is truly global and not everyone is equally vulnerable. The climate crisis is intergenerational, so the damage that we are dealing with was caused by generations ago, and the damage that we are doing will not affect us in our lifetime. It is affecting our children's children and even further. So it's an intergenerational problem. We're also dealing with the fact that the climate crisis is unprecedented. There's never been an issue that affected us globally in this way. And so we just simply don't have the tools, the competencies, the infrastructure to begin to address it, which is a real concern. So climate change is, of course, very global, as we recognize. And what we mean by that is that the impact isn't realized at the source. So the carbon emissions don't stay above the smokestack. They don't stay above the state where they're emitted. They don't stay even within the country where they are emitted. And they're distributed and impact people who absolutely did not reap the benefit from the emissions. So when we test carbon over California, much of it was created in China. And when we test carbon on the East Coast of the US, much of it came from places like California out west. And American emissions end up in Europe. And so we have this cycle. So it doesn't just cross states or industries, it actually crosses international borders. Climate change is also not caused by single individuals, although we all contribute to it as individuals, and I think that's important not to let ourselves off the hook for. But it's not caused by single people or countries or even industries. But instead, it's a vast number of individuals and economic, social, and political institutions who aren't united by a common structure or plan. So it's a whole lot of individual actors feeding into a common problem. And it's complicated because of its intergenerational nature. Carbon, once it's emitted into the atmosphere, is going to stay there up to about 200 years. And so we have a real lag effect. Even if we stopped all carbon emissions today, just went cold turkey, stopped, the planet is going to continue to warm for at least the next century and probably the next 2 centuries before it will finally begin to cool back off. I want you all to think of a warming planet like cookies. This is always the example I use with my students. So when you put cookies in the oven to cook, you don't wait to take them out until they look like finished cookies, right? You take them out when they're still barely starting to brown up on top and they're still really soft, because you know they're going to continue to cook for a few minutes after you take them off the heat. And climate works the same way. Carbon emissions are only the first step in the beginning of a chain reaction of processes. So we see this lag. And I think at the beginning, I showed you those comparisons of the rise in fossil fuel emissions and the rise in global temperature. And there's about a 20 to 30-year lag effect before we really start to see the impact of that carbon. And that's going to be the same with things like sea level rise. The emission of the carbon and the actual sea level rise are going to have a lag effect. In a way, the effects we see today are caused by emissions that were decades ago. And what I always say is it sometimes seems that in a way, we are fighting a past that we ourselves didn't contribute to. and contributing our own emissions to a future that most of us will not live to see. And that intergenerational effect makes things really difficult because sometimes it's hard to see the benefit of our actions when we know we won't actually live to see that benefit. And because it's global and not subject to borders, basically the whole world has to participate for solutions to be effective. So our current global system is basically built on the concept of the nation state, this independent region that governs itself. And this means that nations are free to opt in or opt out of international agreements, and we have minimal way to hold each other accountable. We can't, there are limits to the sort of sanctions that we can put on each other. We don't have global governance, and we also don't have global oversight. And we have to remember that not everybody contributes equally. You know, we talked about those wannabe herdsmen sitting on the outside. I earlier told you to sort of remember that stripe across the map of places that are likely to become uninhabitable by 2070. Parts of Central America, parts of North Central Africa, Pacific Islands, parts of Southeast Asia. And, you know, compare it to this map. A lot of the countries that are going to be most affected are not the places that are big carbon producers. So, but everybody has to be part of the solution. So if we make an international agreement like Paris and India or the US or China just decides they're not going to do their part, emissions won't be reduced enough. But if developing countries who are really just starting out and trying to develop go the path that we went and develop cheaply and more easily by using fossil fuels, then they're going to make up for the damage that we're reducing, and we're back at square one. So we're not actually solving the problem. So when thinking about change, I'm sure you've all seen this image before, it's important to recognize that we need to think about equity because we don't all start with the same level of responsibility or in the same place. And this is that very classic image illustrating the difference here. That's definitely true when we not only think about who contributed the most to climate change, but the nations that have the resources to be able to sort of go this better path. New energy technology is really expensive to develop, and it's even more expensive to buy from someone else. It usually requires entirely new infrastructure, which also comes with a very high cost. And so requiring developing countries to adopt renewable, sustainable technology is adding a real barrier to economic development, which affects the quality of life of people. And I think globally, we would like to see the people at the bottom increase their quality of life, but that comes with an energy cost. And we want, ideally, to see them avoid the mistakes that countries that got rich on fossil fuels made and develop sustainably. But many of these countries see this as a barrier, something holding them back. And the solutions themselves can also be disruptive. So think of the transition away from coal here in the United States and the decimation that we have seen in US coal country. Whole communities built, whole regions built up around this fuel, and they are dying as coal-fired power plants are increasingly taken off of line every year. Coal miners can't just pick up and move to new energy jobs, which is often what we hear. Oh, well, people who work in this industry, we'll just train them to work in a different industry. But that's a hand waving over a very real problem. This is especially true when it comes to new energy industries that require higher levels of base education and technical skill to be able to do. So the consequences and often these new industries are not being built in the same places. So we're back to this concept of place and forced migration. And the consequences have been clear in coal country in the US. So high unemployment, low levels of education, increasing poverty, and this increasing industrial shift where there's just nothing, there's nowhere for these people to work, to go, and their communities are suffering from that. And we see this in places like Western Pennsylvania or West Virginia. It's hard for people to make transitions and just pick up and move. The term that I like that I've seen in the literature is economic refugees. So they're not climate refugees in the same way, but economic refugees from a changing industry forced by climate. And don't forget what we said about the concept of home. One of the things that I think makes me the craziest is when we are willing to apply concepts or embrace a value in another part of the world that we're not also willing to recognize here at home more familiarly. People in West Virginia are just as attached to the land, to places, as the Marshall Islanders. It's part of who they are. It's part of how they define themselves. And it's incredibly important that that community is important to them. Maybe the area is not threatened by sea level rise, but it is becoming unlivable due to opportunity as we switch industries and move away. And I'm not suggesting this isn't a good idea. We have to move away from coal. The consequences of not doing so are enormous, but there are consequences to that shift, and people get left behind. And I think that's important. The implications are broad. We see it in economics, we see it in terms of social mobility, and I'm not trying to get political, but we also see it electorally. We saw 2016, and there's a very real sense of being abandoned in these parts of the United States. And it's similar to what we see in refugees in other parts of the world. They sort of feel like they're left behind or ignored. And that their lives are being threatened by forces that they can't entirely control. And it won't just stay here. I mean, we're used to this with coal. But as we move more and more renewable, are we going to see similar patterns in places that have built around oil? It seems inconceivable right now. But the goal is, if we're reducing fossil fuels, Texas and Oklahoma have to be looking pretty uncomfortable at things like this right now. So let's go back to the Marshall Islands. They contribute almost nothing in terms of carbon. And the area is, they're not a wealthy country. They can't afford to put in mitigation methods to slow down sea level rise. Yet they're being inundated by the sea. So when we talk about equity and recognizing that they're being hurt by a problem that, frankly, we did a whole lot to cause, what do we really owe them? We could say the same thing about countries in Central Africa who want to modernize, want to build up opportunities and infrastructure to improve the quality of lives for their people. But we're part of the international group trying to put restrictions on the fact that they shouldn't be able to develop using cheap and easily accessible fossil fuels. What do we do to help these countries do that? What do we really owe them? And how will international treaties affect the way that these countries move forward? So if we think about the Marshall Islands, more than 15,000 of those places. John, remind me, we're done when?
At 11:30, but you go till you're done and we will move things around.
Okay, I'm maybe just a couple more minutes. We got slowed down with the issue at the beginning. So we have all of these Marshall Islanders in Northwest Arkansas, and as Donna Davis told us, that they're not eligible for a lot of the same social services that would be available to our citizens. So we have to think about what our responsibility is, and that all of us benefit from an economy that has contributed to sea level rise globally. But a lot of that damage came a long time ago, and how do we sort of bear our own responsibility for that? And it's easy to say, yes, we should give the Marshall Islanders social services, and we should. But there's 60,000 more of them that are about to need a place to go. And as Donna Davis told us, they're likely to think about coming to Northwest Arkansas. So we're going to see that. And if we expand it, to international meetings like the one that led to Paris, you had an awful lot of developing countries who argued that their countries shouldn't have to follow rules that Western countries didn't have to, and that countries that caused climate change need to bear the financial brunt of correcting it. And that countries like the US and countries in the EU and China and India need to subsidize sustainable development of other countries or pay to acquire land to move these people to, plus the costs of improving their own infrastructure so we don't cause more of this. And it adds up. And I think we really have to think about how much we as individuals, because this is going to affect all of you, are willing to pay for what we think of as climate justice, and what that really looks like. So Hardin tells us that the only way to solve collective action problems is not through awareness, which I know we all like to talk about awareness of issues, but Hardin says is not enough. That makes you feel guilty for a few minutes and then you're done. He also says that forced policy is also not effective for very long, but that what we want to strive for is mutual coercion, this mutual coercion mutually agreed upon, or agreements that sort of give us something good to to sort of bear that cost. So if we, the example I always use, things like taxes. Nobody likes paying taxes. It's to my benefit not to pay taxes, but I also like the services I get. So it's something that I'm willing to do. So again, we're at this idea of trying to get people to make decisions against their own interests. And what I want all of you to think about is, what's going to sell you? How are we going to get your generation to be willing to make some of those sacrifices that will be necessary? Hardin tells us technical solutions aren't enough, and that if all we do is rely on geoengineering and clean energy, all we're doing is kicking the can down the road, because climate change is a problem caused by the way we consume, by the way we live our lifestyles, and by this tendency to act in our own benefit rather than thinking about the collective. And so I think that that is a really important point. International cooperation is going to be key. And I think all we have to do is look at the results of the Paris Agreement to tell us that. So these are from data from 2019. I know I've seen a more updated one, but I couldn't find it the other day. This is sort of looking at carbon emissions and whether the things put in place since Paris are actually keeping these countries on track. And what we're seeing is that they're not. By and large, without enforcement mechanisms, countries are not living up to that agreement. Now, nobody wants catastrophic climate change. None of these countries would sign up for it. But much like our herds people, they're acting individually instead of collectively. So they prefer the free rider option, that opportunity to keep doing what they're doing and then sort of see if everybody else will pick up the brunt. So looking at the countries that are sinking beneath the waves, I think that, we got to think about how we're going to address this as a global community. Kiribati, I think, has been a real leader in this, finding land in Fiji, beginning to invest heavily in farming that land and in doing vocational training and things to allow Kiribatans in the future to be able to thrive and be successful in a place that doesn't have the same economy. Kiribati, its economy is based around coconuts, and you're not going to be able to do those same things in other places. So being able to diversify that, that is the result of recognition that this problem is coming, and it is coming quickly, and that we have to be proactive rather than reactive, which is, I think, if I have a real message, that we can't just sit back and wait to be reactive to the changes that we know are coming. Even if we stop emissions today, islands like the Marshall Islands, islands like Kiribati, they are going to face real consequences. And so we don't really have the option of just saying, well, this won't happen. That proactive community response is really going to be key. And we have to think about, kind of what that looks like. So yes, we need the science and technology, and science needs to play a real role in leading, giving countries opportunities to be able to both develop and develop sustainably. But we're also going to need other things. We're going to need things like policies for temporary international migration and even permanent international migration due to the climate crisis. We're going to need humanitarian visas that are specific for climate. And we're going to need international money for cultural transition, for vocational programs. And we need agreements that let us plan in advance where people are going to go, hopefully minimizing the kind of disruption that we've seen with climate refugees being sent to parts of the world where they have no connections and have minimal resources. I'm not in favor necessarily of not advocating for global governance, but we do have to recognize that we live in a connected world where our actions affect other countries. And so we can't be quite the same independent actors that we've seen in the past. So the questions we're sort of leaving with are these, just things to think about as we look at proposals for climate change, and to hopefully help us stay out of the risk of just focusing on nothing but the science, balancing the rights and responsibilities of the developed and developing world, assessing responsibility for future generations who have to live with the climate we're shaping today, and evaluating the risks and rewards of technology without over-relying on those. I was super excited to come and talk about this issue today. And I think this is such a cool thing. And you asked me to talk about climate change, and I'll do that all day. But it is also overwhelming because there are so many directions that we can take. And the consequences for real people are real. And that's where I want us to center. It's very easy for people to get lost in these big discussions of science, technology, and global public poverty or public policy, and to remember the very real cost to people, especially poorer people all over the world. So I will sort of end here with, this is yet another, I love space photos. This one's from the Apollo 8 mission. And it's just a reminder that we don't have anywhere to go, regardless of what Elon Musk says. Like, we're not escaping to Mars, we're not colonizing the moon, not in a timeline that is going to solve the climate problem. And even if we do, we need some behavioral change so that we don't see the exact same problems. For us here in Arkansas, the Marshall Islanders are sort of a canary in the coal mine to give us some information about the change that's coming. So I hope that what we've done today is encourage you all to think a little bit more about people and equity in a discussion that often gets framed only through the lenses of science and technology. So I'm sorry I went a few minutes over, but I'm looking forward to talking about this a lot more during your seminar.
All right.
Stop sharing.
Exceptional.
There we go.
Exceptional.
Absolutely marvelous. That is one of the best, as someone who came out of the NGO world, that is one of the best summaries I have ever seen of all of the issues on this.
Oh, thanks.
So
Yeah,
fabulous.
amazing. Your slide deck, amazing too. Wow.
I pride myself on my slide deck creation.
Yeah, no, really very carefully and artistically done. A disturbing subject.
Yeah.
All right, so our habit and custom is to take 15-minute break. So we will I can't do math. What does that mean?
11:56.
Okay.
I think you all deserve it.
We will commence the seminar at 11:56. So see you in a bit.
Is it the same link?
Yep. Or